Hello everybody, welcome back to Edu-Malanga, where we give you the inside scoop on Matric mathematics. Cool, right? Yeah, this channel is dedicated to helping you do well in your Matric mathematics so that you can get great results and get into a good university. We're now working through the trigonometry section of Matric math, and we are at the beginning. We're revising grade 11 stuff, so none of this should be brand new to you. We're looking at special angles, and today we're going to derive the special angles as well as the special angles table. Let's get right into it then. What we're looking at on this page is an equilateral triangle. So this triangle, it means all our sides are equal. It's equilateral. And what is the length of all these equal sides? The length is 2 units, so 2, 2, and 2. There's another special feature about equilateral triangles, and that's all the angles are also equal. So you're going to have 60 degrees over here, that's the angle. You're also going to have 60 degrees on this side, and the last angle will also be 60 degrees. What we've gone and done to this triangle is we've bisected it. Bisect means cut in half, guys. We're cutting it in half along one of the angles. So this is going to be 90 degrees. And because we're cutting in half, this is going to be halved, the length of this side. So you're going to have 1 and you're going to have 1, as well as the angle over here. That is also going to be halved, and you're going to have 30 degrees and 30 degrees on this side as well. Let's rewrite the half triangle on this side. Remember, we have 60 degrees, that's our angle over here, and we have 30 degrees, and then the sides were halved. We went from having 2 units to 1 and 1, so this will be 1 unit, and over here the side stays the same, that's equal to 2. We also know that this angle is 90 degrees, and what are we missing? We're missing the length of this side, so we don't know how long this side is. Let's put a question mark, and let's call it maybe x for now. I've made it small because I want to write down the final answer and make it all look nice over here. Because it's a right-angled triangle, we can use trigonometry to solve for x. Let's use one of the angles to solve. We'll choose 60 degrees. We're solving for x, so from SOHCAHTOA we know that the sine of an angle is the opposite length over the hypotenuse. Cool, so we're going to use sine 60, yes. Sine of 60 degrees is equal to the opposite length, which is x, we don't know it, divided by the hypotenuse, which is 2. Let's multiply by 2 on both sides, times 2 on this side and times 2 on that side. The 2's will cancel out on this side. So what you're then going to have is that 2 sine 60 degrees is equal to x. Guys, you're going to need a calculator to solve this. Put this expression into your calculator, and please make sure that your calculator is set to degrees, and enter 2 sine 60. You will find that x is equal to root 3. And so this is the length of this side. Let's enter root 3. This is the first triangle that shows us special angles in trigonometry. The special angles are 30 degrees, 60 degrees, 90 degrees, and 45 degrees. So this triangle has us covered on 30 and 60. Let's look at the next triangle now. This one is going to have us covered on 45 degrees. So what we have now is a square, and our square has 1 unit length on all sides now. So 1, 1, 1, that's the unit length. And all the angles of the sides are obviously 90 degrees because we're looking at a square. And what we've gone and done is we've bisected it diagonally. So we're cutting this diagonally across one side to the other. And what that's going to do is it's going to turn our angles to 45 degrees over here and 45 over there, as well as on this side as well, 45 degrees. Let's redraw the one triangle again. So we're going to choose just this one. We're going to have 90 degrees like we had before. Then we're going to have 45 degrees, and we're going to have 45 degrees. And the last thing to remember is the length of the sides, which were 1 and 1. So now we need to solve for our hypotenuse. Because we have a right-angled triangle, we can again use our trig identities. Let's use cosine this time because we used sine last time. From SOHCAHTOA, we know that the cosine, and we can choose one of these angles, any, because they're all equal. So we're going to choose 45 degrees. The cosine of 45 degrees is equal to the adjacent length, which is 1 unit, over the hypotenuse, which is h. We're trying to solve for h, so let's multiply by h on both sides times h over here. And then let's also divide by cosine of 45 on both sides. Divide by cos 45. What's going to happen is, on this side your h's will cancel out, and on this side the cos 45 will cancel out, and you will have that h is equal to 1 over the cosine of 45. You again need to use your calculator to solve at this point. So put into your calculator 1 over cos of 45 degrees, and you'll find that the answer is root 2. So the hypotenuse of this triangle is equal to root 2. This is the second triangle now that's showing us the special angles. If you have a visual memory, which means you memorize pictures very easily, then you're probably going to find it easier to remember the triangles. This is the one special triangle, and this is the second one. So you want to remember these lengths as well as the angles. So very easily, if you memorize these triangles, if someone is to ask you, what is sine of 45 degrees? If you memorized the triangle and you draw it, you can quickly say the sine of 45 degrees would be 1 over root 2. Equal to 1 over root 2. And if someone asks you what is tan of 60 degrees, let's check. The tangent of 60 degrees, because it's a special angle, would equal to, tangent is the opposite over the adjacent length, so tan of 60 would be root 3. So using the triangles, this is one of the ways to memorize special angles and remember them. There's another way though in which we can remember the special angles, and I'm going to show you. This is how I understand them, because I remember patterns more. So if you memorize using patterns, this is going to be great for you. First, we write them down in the table. We have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and the last special angle, 90 degrees. So now that we have the angles, let's write down the trig functions. We have sine. We always start with sine, then we do cosine, and then we end with the tangent. Why do we start with sine? It makes it easier. SOHCAHTOA. So now let me show you this very easy way to remember the special angles. We'll start by using fractions, and we're going to work with sine and cosine only. We'll do tan at the end after completing these. And what we'll do first is we'll make everything into fractions. So we're going to have a fraction here. Let's put our fraction division bar first. And then what we're going to do as well for sine and cosine is divide everything by 4. So everything will be divided by 4, divide 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 by 4, everywhere, guys. So this is an easy first step, right? The next step now is to write down the numbers 0, 1, 2, 3, 4. That's how sine works. You start from 0 all the way to 4. And for cosine, you do the opposite. You say 4, 3, 2, 1, 0. Looking pretty easy so far, right? Yes, and then the next step is we're going to take the square root of everything. So everything gets a square root in all of them. Yes. And now we simply have to simplify. To simplify, we have to understand how our square roots work. Remember, when you take the square root of something, let's choose x, this is equal to x to the power 1 over 2. So a root is actually an exponent. It's important to know this because then you know that your roots will follow the same laws as exponential laws. So in a case where you have the square root of x over y, that's equal to root x over root y. So let's simplify using that understanding. The sign of 0 over 4, 0 over anything is just 0, doesn't matter what you do. So we're going to have 0 for a start. Then the sign of 30 degrees is the square root of 1 over 4. The square root of 1 is just 1, and the square root of 4 is 2. So that's the second special angle. Let's use 45 degrees now. Sine of 45, you have the root of 2. We can't simplify that, so we'll keep it as root 2 over the square root of 4 is equal to 2. And let's do for 60 degrees. The square root of 3 is simply also going to be root 3, and the square root of 4 is going to be 2. And the last sine special angle is square root of 4 over 4. That's square root of 1, and that's simply equal to 1. And for cosine, it's easy to solve. Nothing is new over here, guys. We're going to have 1, and we're going to have 0. And then we're going to have root 3 over 2. And we're going to have root 2 over 2. And the last one will be 1 over 2. So these are the special angles for cosine. How do we solve for tan now? To solve for tan, we have to remember the special relationship, and it's that the tangent of an angle, so if you have tan of theta, it's also equal to sine of theta over the cosine of theta. So we're going to use division. We're going to make this divided by that, because we're going to have sine of theta, our angles are the same, divided by cosine of theta, and that's going to give us our tangent values. So let's do that. 0 divided by 1, that's equal to 0. That's the special angle for tan of 0 degrees. Okay. For 30 degrees, we have 1 over 2 divided by root 3 over 2. Let's write it down. 1 over 2 divided by root 3 over 2. Remember, when you are dividing one fraction by another, you simply swap the numerator and the denominator of the fraction you're dividing by and change the sign to multiplication. So this is going to be equal to 1 over 2 times 2 over root 3. The 2's will cancel out, and you're going to have 1 over root 3. So this is the special angle for tan of 30 degrees, 1 over root 3. Let's do the rest of them. Root 2 over 2 divided by root 2 over 2. Anything divides itself, you get 1. And the last one is 60 degrees. I have root 3 over 2 divided by 1 over 2. I'm going to make it easier for myself. I'm going to say root 3 over 2 times 2 over 1. I've already swapped it around and changed the sign. That's equal to, these will cancel out, root 3 over 1, and it's simply equal to root 3. Root 3. And the last special angle is tan of 90 degrees, which would be 1 divided by 0. Anything divided by 0 is undefined, guys. If you enter it into a calculator, the calculator will say error, and you know that the answer is actually undefined. So this is the second way to remember the special trig angles. I've rewritten them very neatly on this table, just so you have a picture of them. This table shows the working out, and this table shows the final answer. If you're able to also remember this because you have a good visual memory, or you can just see the pattern where you have 1, which would be 4 over 4, and then you have the 3, the 2, and the 1, and then the 0. You may also use this table to remember. We're almost done with the video. Let's do a quick check to make sure that this table corresponds with the special angles that we derived when we were looking at the triangles as well. We're going to start with, for example, the sine of 60 degrees. So when you take sine 60, if you look at the table, sine of 60 degrees is root 3 over 2. Root 3 over 2. Let's use the triangle to check now. Sine of 60, this is the triangle. The sine of 60 degrees will be the opposite length, which is root 3, divided by the hypotenuse, which is 2. So again, you're going to have sine of 60 be root 3 over 2. So that checks out in both the table and the triangle. Let's do another example. Let's take tan of 30 degrees, and now we'll use the triangle first. Tan of 30 degrees, this is our 30 degrees. The tangent of it will be the opposite length, which is 1 over the adjacent length, which is root 3. So this is going to equal to 1 over root 3. Let's check it using the table now. Tan 30 degrees in the table is 1 over root 3. So again, this also checks out. And so these are the special angles in trigonometry, guys. I hope I've explained them well and that you understood everything that I did. If you have any questions, leave them for me in the comments section. I'll try my best to answer all of them. Thank you for joining us. Join us again in the next video where we will do even more grade 11 revision.